Now we're going to try to find the following limit. So the limit as x goes to 1 of 1 over ln of x minus 1 over x minus 1. So the first thing that we do is that we check the domain. So here we have x must be positive for the natural log. The natural log of x must be different from 0, and x must be different from 1 from here. Okay, so but this one here is the same because the log is 1, 1x is 1. Therefore we have, and x is bigger than 0, therefore the domain is going to be 0, 1 union 1 plus infinity. Okay, so now we're going to try and evaluate. So here we have if we get to 1 from the right, so here 1 over 0 from the right is going to be infinity, minus 1 over 1 from the right is going to be infinity. Therefore we have infinity minus infinity, and this form is undetermined, so we can't conclude. Okay, so to make this one work in using L'Hopital's rule, we have to do it in somehow. Okay, but I think the best way is try to cross multiply and see what we can get. Okay, so let's do that. So the limit as x goes to 1, so if we cross multiply, we're gonna get x minus 1 minus ln of x over x minus 1 times ln of x. Okay, now we evaluate again. So here we have 1 minus 1, which is 0, minus 0 over 0 times 0. So here we have 0 over 0. Okay, and this is great. That's what we need. We can't conclude, but this is good, so we can apply L'Hopital's rule. So what we're going to do is we're going to differentiate this one and over this one. Okay, so the limit as x goes to 1, okay, this one here is going to be 1 minus 1 over x, and here in the bottom is going to be ln of x plus x minus 1 over x. Okay, now let's evaluate. So here we have 0 and 0 plus 0, so the same thing, we have 0 over 0. Okay, and therefore we can apply L'Hopital's rule again. Okay, so let's see what we can do again. So now we differentiate again. We're going to have the limit as x goes to 1. So here we're going to have 1 over x squared, and in the bottom we're going to have 1 over x plus x minus x plus 1 over x squared. So if we try to write this one nicely, we're going to get this one is going to go and multiply by x, so we're going to have 1 over 1 plus x. Okay, now we evaluate when we get 1 over 2, and this is our limit. Okay, so therefore the limit of 1 over ln of x minus 1 over x minus 1 as x goes to 1 is 1/2. Okay, so it's either from the right. We did it from the right. Okay, so because we have to check both limits, from the right or from the left. Okay, so this is a limit from the right, and it's 1/2. Okay, so the next thing that we're gonna do is when we check the limit from the left, we can use the calculator to make sure that we get this limit from the left, and without doing any other work, we can just make sure that we get the limit that we need. So if we do, let me see if I have my calculator here. Okay. Okay, so if I can use this one here, I can see if I can get this one from the left. Minus 1 here, and it's still, if you do it from the left, you're still gonna have the same limit. Okay, why does it work in for both from the left and from the right? Okay, because we still gonna have the same one here. Okay, so when we get here, so this is goes to infinity when where if this one, if we go to 1 from the right, we have 1 over 0 positive, so we have plus infinity. If we get from the left, we're gonna have minus infinity, and here plus infinity, and still we're gonna have the same problem. So it doesn't matter if we get from the right or from the left, the limit is gonna be the same, because once we do that, when we differentiate, it doesn't matter if we go from the right or from the left. That's why we don't check here. You see the issue here when we get to 1 from the right or to 1 from the left. So it doesn't matter, therefore we're gonna have the same limit for both left and right sides.